Today's topic is the product of sum. The topic code is ELEC-DIGIE-S6B. So again, we have seen that the in OR function or OR gate produces the logical sum of the Boolean addition, and the AND function produces the logical sum of the Boolean multiplication. When dealing with the, here we say the logical multiplication we get and we get, but dealing with the combination logic circuit in which the AND gates or OR gates and NOT gates are connected together, expression of the product of sum is widely used. Product of sum expression comes from the fact that two or more sums ORs are added together, that is, the outputs from the two or more OR gates are connected to the input of an AND gate, so that they are effectively ANDed together. ANDed means the all pooled up into the AND gate to create a final OR AND output. OR gate is fed to the AND gates, OR AND combination output. For example, the following Boolean expression, we have Q is equal to, now these are the OR gates, A or B, B or C, A or 1, B is complemented in this case, then they are ANDed together. Okay, so similarly again there are two variables each, that is the sum is with the comprising of two variables, in this case the three variables we have and two variables combination. So let's move on to the next slide. Now here we can have further Q is equal to A plus B complement C. We can expand the in the expanded form the product of sum. We can also write A plus B complement into A plus C complement. Another non-standard example is Q is equal to A plus B complement plus A plus C. These are all examples we are giving. So further we can have another Q is equal to A plus B complement plus B into the A plus B complement plus C, which can, if required, be reduced to the complement law and annulment law too. So we can simplify them. So now converting an POS expression into a truth table. Now let's see the truth table of this particular expression. Q is equal to A plus B plus C, A into A plus B plus C, B is complemented, A plus B complement plus C, A plus B complement plus C. Here is the truth table, again the similar which we discussed in the previous topic, that is this is the product of sum, that was the sum of the product. So we have got again the three input variables, we have got 8 each, combination of the 0 and 1s. So we divide the 8 into 2 half, that is the half. 8 half of the 8 is 4, so 4 zeros and 4 1s, and then further 4 is divided into half, which is 2 zeros and 2 1s, 2 0 and 2 1s, and further 2 into half, which is 0 1 0 1 0 1 0 1, and so on and so forth. And the Q value, if you just simply apply that gate circuit here, that is the A plus B, put these values and you will get these results. And now what we are looking at, that A plus B in fact is giving all those terms which are zeros. Okay, so A plus B plus C, which are outcome is equal to 0. So whatever you get the putting these values, the 0 outcome is being observed in that case. Again the same table is again written over here, but with the now that Q, this is the expression now with the how many, 1 2 3 4 products. This is now the sum of products, which is the sum are being multiplied. So using the truth table, we have the three inputs, but with the 4 expressions. again output are equal to 0. So again C is, the variables have 8 input, the C combinations would have 0 and 1s, 8, and similarly 8 for B and 8 for A, but each one, then we, in order to put them in order, we take the 4 zeros and 4 ones, 2 zeros and 2 ones, 2 0 and 2 ones, and then 0 1 0 1 each 8 times we put, and the out, these results are obtained by putting these values 0 0 0. If you put 0 0 0 in this all cases, what we get? 0. Let's do one example. A0 B0 C0 means 0 plus 0 plus 0 is 0. This whole term, the first term is coming 0 means everything is now 0. Whatever you get from the other, that doesn't make any difference, so it is 0. So again, now put 0 0 1. So if A is 0, B is 0, okay, in this case is sorry, A is 1, A is 1, B and C is 0, so this is 1. Now put here A is in this case is 1, B is 0, okay, 0 is again 1 because 0 complement, C is 0, we are doing this one, this second row, so it is again 1, again A is 1 but A complement is 0, but here C is 0, C complement, 0 complement is 1, so we get 1 from here. Again A is 1, the 0 complement is again 1, the C complement is again 1, so we get 1. So we get 1 from each term. So product of is 1 into 1 into 1 is 1, so outcome is 1. But actually what we get here, that is the term A plus B plus C, that particular terms which are giving rise to the zeros, these are those terms are written over here, and these are the other terms which give rise to the ones. So we can have the, but normally these individual terms are giving rise to the zeros which are given as in the respective expressions. Now this is the logic gate diagram. Let me expand it one more. Okay, this you can see these are the, okay, let me bring it back. So okay, so we have the logic gate diagram for these are the sums A plus B plus C, A plus A again are being multiplied. So we will have 4 OR gates, and similarly if we have got any NOT gate, we will introduce that one, and then we put all these 4 OR gates to the one single AND gate. So here we have got because there are 4 terms of sums, so we need that 4 OR gates. A, B and C, they are fed into the first OR gate, get A plus B plus C. Then we have the second OR gate, which is A plus A or B complement plus C. We put a NOT gate and get the complement. In the third gate, we get A complement. We put another the complement over here, which is A complement, and the B is taken directly from here, and C is taken from here downward. So A complement plus B plus C complement, and the last A plus B complement plus C complement. A is not complemented directly, we have dropped the wire here and fed into it. So all these 4 OR gates are fed into the AND gate to get the product of sum. Okay, so that is how we represent the logical Boolean expressions in terms of the logical gates. These are also termed as interconnecting the gates. So with this we reach to the end of this topic. Thank you.